Hey everybody, this is Larry. This is me doing the extra question on just an extra question for today. It's December 4th here in New York. Yeah, I'm just going to do a pick one. So maybe it's easy, maybe it's hard, maybe it's medium. We'll see. Okay, I clearly did not filter out because I already did that one. So let's do it to do. Okay, now let's pick a random. And today's problem is bricks falling when hit. It's a hard problem. It's actually not a premium problem, or at least I don't see a premium tag. So I don't know. So hopefully you'll be able to do it with me. Okay, so you're given an n by n, which I always read as R and C, a binary grid where 1 is a brick and 0 is an empty space. A brick is stable if it is directly connected to the top, or at least one other brick in its 4 adjacent cells is stable. You're given an array hit. Each time we want to erase the brick, and then the brick on that location will disappear. Some other bricks will no longer be okay. So will we have multiple hits? Let me see. Okay, so there are a lot of hits, and we have to kind of think about all of them, right? So I guess the first question is to figure out. I mean, just make observations, right? The first thing I'm trying to think is whether. Okay, so if it falls, it is erased. Okay, so I was gonna wonder if there was like some weird thing where we have to keep on doing it. So I think that's actually not as bad. I think it feels like almost like an opposite um, direct components thing, right? Or connected components thing, where, well, usually you start with nothing and then you start, doing connected components with union find or DSU disjoint union set or disjoint set union. Disjoint set unions. But this is the opposite of that. So then the question is, so the worst case in this thing, and I should look at the grid a little bit. It's 200 by 200. So, but if you do a simulation every time, that's going to be n squared, where n is the number of cells, and the number of cells is 200 by 200. So it's going to be 200 to the fourth, which is too slow, right? So we have to think about, is there a way that we can think about it, right? Um, hmm. I have some ideas around, articulation points and stuff like this, but well, let me. But like you can remove two things, right? And I don't know if that's in one of the examples, but you could remove two things and then it falls, right? So that's not necessarily good enough. Mm. And the thing is that you can't really recalculate, all the cells dependencies every time something is erased, right? Um, mm, so we have to. So you can't just do like I mean, unless you know that you're going to erase them for sure. If one thing I'm just thinking of right now is visualizing it in terms of a tree, and like maybe not a tree. Maybe tree is not the right way of thinking about it. Ugh. How do you do it? Hmm. I don't know that I know how to do it off my head. I have to kind of hmm. Mm, okay. I mean, one may be obvious, but I'm still going to say it specifically. One thing to note is that when we destroy or hit one of these ones, we only have to look at the adjacent ones, right? So that's one. How do I measure whether this is disconnected? Can we? Okay, so let's say everything is in before, right? Mm, yeah, and you can't really update every time you destroy something. Huh, that is tricky, huh? Okay, so I'm honestly I was just thinking about some sort of data structure. So I'm thinking about simulation, but a simulation that allow some way of for us to update in an earlier time. But it seems like I don't know that I have that. And then maybe the opposite way is, and I don't know if I can do it, but just this is just me thinking through different ways of thinking about it. It's the opposite of like, okay, let's say let's say for each cell we go, well, what I was going to say is that for each cell we calculate like when would it become unstable, right? And then four. So like almost like, okay, here we look at, like for this cell we look at and then that's 200, that's 40,000 times 40,000, so that's still too slow. But what would that even look like, right? Like if we do it naively, that'll be too slow. But what if we look at the cell and we go, okay, how can we update this for each hit or something like that, right? Like when do we know when it would fall? And I don't know that I have an answer for that either, to be honest. But I'm just trying to think about different things, right? Mm, is there an algorithm that I am missing with respect to? Let me look at the constraints. Constraint seems pretty straightforward, actually. So, like, there's no weirdness that I missed. I don't think. Maybe we read the bomb. Man, this is why we practice, I suppose. Hmm. I don't know that I have an idea about this one. I mean, yeah, in this case, what if we have something like one oh like a thing, and how do we? So that's really the big case that I'm thinking about, right? Or I mean, you could even think about something like this, really, and then just slowly one by one, how do you figure it out, right? Like if we just do it one at a time. Well, I think one thing to note, and I don't know that I can prove this. I think one thing to know is that, well, I mean, well, the first part is that we can break it into components of just disconnected initial components, right? Meaning that basically, if we have a big enough graph, let's say we have, I don't know, right? In this case, basically we have two problems combined into one, right? So we can kind of not paralyze, but like we can solve them separately, right? I think that's one. And then in that case, I wanted to say something like, if we remove all the heights of one row, then obviously everything below it will get deleted, right? And while that's true, it still doesn't help enough, because, for example, you could get rid of this one and then it will get rid of all the things to the left. It doesn't really help you. And also then you could have stuff like this, like almost like a Christmas tree. And then, like you can get rid of here and then it goes all the way down, right? And I'm thinking about, depth first search still in a linear way. And of course, I don't know that helps, because in that thing, and the linear stuff I'm thinking about is very related to like articulation points and stuff like that. But this doesn't, I mean, I drew it this way, but you can imagine you have like an extra one, and then now you can remove this one, it'll be okay, right? But but you can remove both of these, and then it's no bueno. So I feel like I'm missing an observation about this one. Do I have to be linear? I mean, 200 times, well, 4 times 10 to the 4th is 40,000. So if we we definitely cannot simulate it. And maybe today is not, I'm not ready to do a hard one, but it is what it is. Sometimes you don't get to choose the problems given to you, as they say in life. We don't have a great idea. I mean, even if we do a backwards depth first search, and then we know that, maybe, okay. Let's say we do know all the hits in ahead of time. Can we process this thing, right? Meaning that we go all the way here. Let's say we do a recursion, we go down, 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 left, 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 down, 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 and we know that. But then now we have to do it like all possible paths, which is ridiculous, right? But I think something like that may be an idea. Meaning that we have hits, and an index that ties with hits. Maybe we can do a breadth first search then. Can we do a breadth first search, Larry? Because I always think about that first search, but maybe breadth first search where this is 0, 1, 2, 3, 4, and then now it goes to here, and then now here it knows the latest that it gets detached, right? But that's only for here, right? What if I have something like here? Then where do I start the breadth first search, right? Mm, and what is it a breadth first search on? Well, the breadth first search is on the mm, because for example for this one or even for these really, let's say we know that all these four gets hit. How can I do a breadth first search in a way such that yeah? Oh, maybe I could do the hits backwards. It's that the way to do it? Then now, for example, we process all the hits, and then now we all drop all these things, right? And then now we add them back one by one, and then with union find we can determine when these hits get added back. Okay, wow, that's a really I don't know. Maybe I'm just also dumb today. I think that's the way to do it. But also, wow, 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 wow. All right, let me think. I mean, I think that's the idea now. Actually, to be honest, um, yeah, I think that's the idea. And now I'm trying to think. Now I'm trying to think. What do things look like, right? Okay. So basically, for each cell, we check to see whether it fell or not at the end. So basically, okay. I think, and if it falls, then we know that eventually, or that in the beginning it's stable. I think, I guess, right? Okay, I think I have an idea here. So let's play around with this now. Wow, this is possibly a. I mean, this is a hard problem, and I am not. I mean, I had to. I feel like I had some of the ideas early, but not quite. So yeah. Okay. So then we have. Let's just say. Okay. So hits is. Let's just say we have for x y and hits, or maybe differently. We make a copy. Okay, fine. So. Whatever. Not creative with names today. Times C for so let's just make a copy. Okay. And then now we want to look at hits. Right, okay. Man, now this is one of those problems where once you know the answer, you feel so silly for wasting or using so much time figuring it out. But okay. So yeah, and then g2 of xy is equal to 0 because now we hit it. And then now, basically for each cell, we see if it's still connected at the end. Because if it's at, I guess we don't have to really. I think this is fine too. What we want to do is, wait, let me think. So once we connect, okay, I think it's still union fine, but I have to be more careful. Not about, or we have to do the union fine with the sizes. That's all. Okay, I think that's fine. I don't need you anymore. Well, maybe I do. I'll just put it at the bottom instead. Okay. So okay. So parents is equal to x for x. Oh wait, whatever. We just and then sizes is equal to right. And then now you find of xy is if xy in not in parents of xy is equal to xy, say if parents of xy is not equal to xy, then this, and I'm not gonna lie, yeah, I messed this up a little bit, to be honest. I'm not gonna lie. What I was gonna say is that I'm gonna say is that I'm not going over union find for this problem. This is kind of, I have other problems where I go over union find, and I'm gonna just, if you want to Wikipedia it or Google it, or ask chat.openai it or whatever, this is what you would do. But yeah, this is what you find, or this join set, is it union? Data structure. If you Google these, it'll give you details. I am not going to spend time on this particular part for now. Sorry about that. Yeah, and then sizes of key is equal to 1. Right, so this is just okay. And so AB, right? UA is equal to U find of A, UB is equal to U find of B. Usually I just write parents of UA is equal to UB, and then sizes of UB increment by sizes of UA, right? Okay. And we need this because we want to get idea of what connected. Okay, so now that we got rid of the hits, and then we'll put them back on, one by one, we can go through it again, or go through it first to construct the, yeah. And then maybe I'll write something like parents of, I don't know, whatever, 0, or I don't know, roof. It doesn't really matter because Python is silly, but is equal to roof, right? Yeah, whatever. And then didn't I have some stuff back to? Okay, fine. Well, let's connect stuff for the roof first. So for y and c, if grid 2 of 0 y in the first row is equal to 1, right? Then we connect it to the roof, right? Okay. Yeah, I mean, I think that's roughly right. Basically, we want to connect it, right? And then now we go, yeah, we just connect left, right, and stuff like this, and all this stuff together. So yeah, so and you can also look at only one direction. So I think that's fine. Okay, fine, we'll do that. So union x. Oh, this is only if this is 1. If g2 of 0 xy is equal to 1, if g2 of x plus 1 y is equal to 1, what am I doing? X plus 1 is less than r, and this, then we union this, right? If y plus 1 is less greater, yeah, I'm not saying the right words, but I'm typing the right things, which is maybe more important. So okay, so now we union all these things, right? And then now now we have the idea of what it looks like without the hits, right? So maybe for testing purposes, I'm just going to print out, or I think maybe I have to do sizes as equal to 0, just so that I, oh yeah, okay. So roof contains, Huh. Oh, I see. That's the parent. That's a really awkward way of doing it. But okay. So you could see that there are two different parents, if you will, or two different roots, if you will, which because we got rid of 1 0, that's the case, right? So far so good. This is what we expect. Let me also look at the other one. And this is all 0. Yeah, so I think this is what we expect. So that's good. And then now, yeah, basically, yeah, and then now we just do the hits in reverse. So I don't know. Let's just say Q is equal for queries is rival Q is equal to the length of the hits, and then we just do for I in range. Yeah, okay, fine. In range of what's it called? Q minus 1 minus 1 minus 1 to do all the hits. And then XY is equal to hits of I, right? And then now we're hitting this number or hitting this thing. And what does that mean? That means looking at adjacent cells. We're looking at adjacent cells to kind of get the count, right? So basically, so we look at, yeah, and I thought I could avoid it. Maybe I should have just done it. And this is just like the direction, the 4 cardinal directions. And then basically for dx dy in directions, and then maybe like a count is equal to 0. We have an answer array. And then basically and x and y is equal to x plus dx, y plus dy. And then if this is within bounds, and g2 of nx and y is equal to 1, then what do we do, right? By the way, at the very end, we should set it to 1. I don't know if that's necessary. I think that's necessary, actually. Yeah, I think that's necessary, actually. Yeah, okay. So basically, yeah, if this is the case, then we can do some. I mean, you have to write a little bit more, Larry. I mean, this is definitely a subcase. Oh, I don't know what I'm saying. But basically, we have to find that they're not. So basically, you look at that direction to see if it's already connected to the roof. If it's not connected to the roof, then no bueno, right? Is not equal to u fine of nx and y. If it's not connected to the roof, that means that adding this thing. Wait, let me think about this. I think we have to do some more cases, because basically what I'm thinking of is this case where, let's say I have like 1 1 0 1 1, and then 1 1, right? And then maybe 0 0, right? And let's say we added this 1. That doesn't mean you save the rest from falling. Because then you have to hit, keep going, and then this has to be 1 and this has to be 1, and then now you're connected to the roof. So maybe we have to see if this is connected to the roof first, right? Okay. Okay, I think I got it, maybe. I don't know, actually, to be honest. So if this is not the case, then we count is equal to sizes of nx and y. You find of this, right? Yeah. If or else, if it is connected to the roof, then roof is equal to found. Found is equal to true, maybe. So found is equal to false. So if found is equal to true, that means that there is a way to connect it to the roof, and then all the other ways are falling out, right? So then answer that append count. Yeah, I think that's pretty much it. We return answer. We have to reverse it first because we're processing the queries in reverse order, and of course we have to connect it to components. So we have to do this thing again. Yeah, I think actually we could do it here. Could be wrong. I don't think I need another loop. Right. Let's give it a spin. Maximum recursion. Oh. Yeah. I made that typo a lot actually. What line is that? 70. I mean that's fine. I just need okay, I erased some lines so I don't know. Okay, this one. Yep. Okay, so that looks good for these two cases. I'd give it a submit. I mean, I think the idea is going to be right. If it timeouts, then I don't know what to do, but or at least I have to think about it a little bit. Okay. Well. Oh, whoops. Though it should return like 1 or something, but let's kind of see again. Oh no. Let's see what happened. I did. This is a legit answer. I forgot to. I mean, you know, if there's no hits, I don't return. I don't put in the answer. Somehow, I guess the test cases are. Wait, I got this test case right? Maybe just count as 0, and that is was found. That's really awkward. Oh, I guess so, because found is and then count 0. Okay, fine. But we do need an add extra case. Okay, at least that's consistent. So this is basically a column. I'm returning zeros. Oh, I see. Basically, I mean, I'm missing one thing, which is that you know, going here. Okay. So basically, we're hitting here. Okay, and then at the very end, we set this to 1. If x is 0, 0, we union it to the roof. To the roof. I guess I missed that case. Or, yeah, I mean, I didn't test for it. Still wrong answer, huh? Maybe time limit? I don't know. A lot of cases to miss, to be honest. Alright. Yikes. Isn't that the input? No, that's one of the places that we add, though. Okay, so we're hitting 0, 0, 0, 2, and then 1, 1. Which one is 1, 1? The middle one? Oh, huh. I guess I didn't consider that. I thought the hit bricks have to be. Oh, I thought that it was guaranteed to exist, to be honest. So, okay. Let me think about that for a second. Well, in this case, it shouldn't matter, though. Just 1, 1, 1, and then. That is weird. 1, 1, and then, you know, okay, let's just print sizes, maybe counts. So, okay, so go 1, 1, 0, 2. Oh, I see. basically now where I have to basically it's this thing of this found, but if x is 0 then or x is equal to 0 or something like this. A lot of edge cases the way that I wrote it. Maybe I should have just added in a fake row instead. That's one way to do it. Like a sentinel value almost. Hopefully this maybe not. Oh jeez, so many wrong answers, so many edge cases. Okay, what am I doing wrong here this time? I was just thinking about whether that case is handled correctly. Okay, fine. So 1, 2, 1, 2. Oh, I knew that this was the case, but yeah, because it doesn't exist. So yeah, I mean that's basically the story. If grid, I don't know if this is sufficient, but I guess we'll see. If grid of xy is equal to 0, answer that append 0, and then we continue because. Wait, is that true? Oh yeah, because basically what happened was that I put in a 1 and then yeah, and then I backfilled that 1. Wow, I'm getting a lot of wrong answers on this one. I think the idea is right, but wow, this is hard. Okay, so expected 4, but instead is a 9. Let's see. I don't know anymore, friends. This one's exhausting, clearly. I don't think I've gotten this many wrong answers before, or at least like in a long time. Okay, so you have something like this. First one is 5, 1, 5, 1. This is a miss. So 1, 3. Why did I put 9? There's not even 9 things. Did I miss it? 1, 3 is this one, and then there's only. Also, that's fine. Unless I misunderstand this problem. That is the input, right? What am I doing? Okay, yeah. And only 19 out of 40, so I have a lot of test cases left. Okay. Why do I output 9? I output 9. All right, where's 1, 3? 1, 3 is this one. So in the beginning, I look like this. The only way that I could get 9 is if I'm adding this count. But I thought that that would be. Basically, it's going up, and then we can. Did I check that as 1? Yeah, okay, I do check that as 1. Okay, let's print out XY and X and Y. My watch is telling me to stand up. Oh no, I lost that test case again. Not used to having so many wrong answers. Maybe that's a good thing, but still, I'm just confident, overly confident, maybe. Okay, so 1, 3, we go 2, 3. Oh, I have my pretty graph. 2, 3, okay. Oh, because these. Is that true? I see. I mean, there is another thing that I have to do apparently, is because basically I'm double counting 2 things that are part of the same component, meaning that I don't know how I got 9 instead of 8 though. Oh, because I added itself and then yeah, and then an order of operation thing. Okay, fine. Wow, there's a lot of edge cases. I also should cache this, but it's fine. Okay. Oops. Okay. I thought that would fix it, but clearly not. Oh. Did I start my print statement? Wow. Alright, that's not what the print statement. Just undoing and redoing, but what are you doing? So 1-3. Oh, because after the union, now it is not the same anymore. I guess we could have done it the other way too, which is that if this is equal to u fine of xy, then we continue. I guess that's fine too. Maybe not, because I've been wrong a lot today. Okay, let's give it a submit. Mostly because I'm too tired to think of more edge cases. We're 42 minutes in. This is a hard one. Oh no. All right. Well, let's copy it. I don't know how to debug this really, to be honest. I mean, the idea is right, but my implementation is very bad. Or like there's a lot of edge cases for sure. What am I? Like, what is the? They don't. Is it so long that they don't tell me the what I'm wrong on? Like usually it. See, this is where the new thing. It just doesn't, like literally. Oh no, there's the expected, and there's the output. Everything looks okay. In the old thingy, isn't there a thing where they tell you where it's wrong? How do I put this on the other side? Okay, there we go. There's no chance I could. And then expect it. I feel like there was a I can't. This new UI is like a regression in some way. I don't know how to see where I went wrong, but because in the old one there's a thing that like there's a diff button. I guess the diff doesn't help because the expected is just so long. And we're mostly right, but apparently maybe we're missing a case. Am I missing a case? If this is continue, this is stressful. 5 wrong answers. I mean, still the idea is right. So I'm happy that I got the idea. A moral victory. Oops, no, don't look. Wait, where's my other tab? Oh, this is the tab. But I don't even know how to debug this because it doesn't really tell me what the thing is. So okay, let's take a look real quick. Yeah, now you don't give me the autocomplete. I forget what output and expected. Hmm. 576. Oh, well, there are 2 indexes, which is not helpful, I suppose. And also, that's too much for me to help, really. So am I adding components in? I mean, what else can I be doing wrong? I think if yeah, this is no way to debug it. I mean, I kind of wrote this in a lazy way anyway, so what I want to do is this was kind of weird anyway, so maybe just put this union thing later, and then now we don't have to worry about weirdness. I don't know if that's whatever, but it's still wrong, and now it's wrong in a lot of places. How do I even get a number so big? What did I do wrong? Why is this union weird? XY is equal to hits, yep. So 13 instead of 7. Man, I get some really big numbers. Is a union weird? I get all the other ones right, so it's specific to this one. Same number can be hit multiple times, maybe. Is that true? Maybe that's why. No, that assertion actually didn't hold. Or like it held. I guess it's distinct. Okay. I thought this would at least give me the same answer. In scene add, you find it. Tell me why. Man, my implementation's been pretty bad these days. Why though? All I do is yeah, I mean, this seems right. I think. Why is it so like? How do you even get this? Sizes of. Oh, I see. Because here we only union when. But basically, what we need to do is, if UA is not, you go to UB. We turn if they are the same, then we don't union or we don't update the size there. Wow, that's a really subtle bug. But did I had that before? I guess I had it before as well. Let me give it a minute then. Do I have any print statement? Okay, let's give it a minute. I guess I had it before. I just didn't catch it. A lot of silly mistakes. Some on the union find, which I didn't expect to be honest, but I haven't done it in a while. This was a pretty hard problem, but everything is linear time, I think. And by linear time, I mean O of R times C plus Q, because for each for each query, which is in hits, we only do O of 1 operations with union find. You can kind of, if you want to talk, let's not talk about inverse Ackermann function stuff like this. But for now, let's just say all the union find operations are O of 1, and in that case, and we could have done it if we just add like an if statement somewhere here about which one to combine. I'm too lazy, but yeah, I guess before we were just grouping them together anyway, in a way that kind of mixed it up just enough to mess up. Okay, wow. And it took union. Basically, I dramatically updated the result in a bad way that it highlighted the bug, where the other way, because of the early terminations, it became more subtle. So the other way would have been fine too now, but we wouldn't have. Okay, maybe not. Oh, because we have seen and now we have to do that thing with seen and whatever. Okay, fine. But because it changes to you, fine. Yeah. So like I said, this is so much code. This is gonna be O. Time is gonna be O of R times C, which is linear, right? Plus Q, which is also linear. Space is gonna be, I don't know, O of R times C, also plus Q, I think. Maybe not plus Q. But yeah, maybe no Q. That's all I have for this one. Let me know what you think. Let me show you the top of the code. This is union find stuff, and then the bottom. The key idea, which took me a long time to get, but also longer to kind of get it exactly right with all these edge cases. Yikes. 5 wrong answers. I don't know if it's a record, but maybe I should be not doing these when I'm a little bit tired. But yeah, yeah. Let me know what you think. Let me know how you did it. Let me know if you are doing it. Stay good, stay healthy, to good mental health. I'm going to take a quick nap, so I'll see you later, and goodbye.